Okay, we are recording our session. This is week 12. And what I want to do tonight is just I'll hit a few highlights of where predictive modeling might be headed. While you're working on your final assignment, I'm sort of going to take a look and say what's next. Because even if you think you've mastered everything, of course, there are new things on the horizon. We all know that ensembles are going to progress and so forth. But we'll talk about these things in just a minute here. So let me go ahead with the slides. There's a lot here, as you see from the agenda, and I could basically turn this into multiple lessons if we had time to go through all the details and talk about this. But these are things you really need to be aware of. They're going to make what you've learned in this course and previous courses and upcoming courses even more valuable. Because even though everyone's preaching, oh, and we need analytics, we need analytics, we need analytics, the answer is you ain't seen nothing yet. We're going to need a lot more, a lot better, a lot richer analytics going forward. So I want to talk about some of those things. I think most of you are aware of most of them, but I'll give you a little heads up on some of them, and then a little bit about what SAS is doing going forward. We revisit this slide one more time because, as you recall, we're sort of right here on this niche, but there's a lot of niches, and you move up and down here depending on what it is you're doing and why you're doing it. But we're very heavily into predictive modeling, and now we're going to move, I think you're going to see, moving into optimization. You begin to look for ways to take what you've learned in predictive modeling and optimize the implementation of that. So just one more revisit of one of my favorite slides, because I think it is a very good and important one. And it's from SAS. That helps too. Okay, let's talk about some of the things that are changing. We'll start right here. And these are a couple that we've hit on already a little bit, just to re-emphasize them. Text analytics. You can expect a huge emphasis on that. Why? Social networks, Twitter, Facebook, all these things where people are posting things. What you'd like to do is actually pull out some key aspects from the text and be able to turn that from just word count. You can do a word cloud, which is a start, but a minimal start. But as we talked about briefly, you'd like to turn that into a vector or something where you can use to predict things. One of the most, I think I've already mentioned this, but I'll mention it again, one of the most interesting talks I saw at Predictive Analytics World was a sort of a strange offbeat talk by a couple of very bright gentlemen who were starting their own company and going to get into using what's posted on social networks as a way of evaluating how worthy people are, for example, for loans. It's one thing to have a nice FICO score, 700. Something else if you're posting on Twitter, oh my God, I don't know how I'm going to meet the mortgage payment this month, and things like that. So they wanted to be able to distill some of that information and use that in addition to some of the objective data. That's a difficult thing to do. Difficult, as we talked about briefly, it's difficult to pull out sentiment out of text. You can pull words, you can pull grammar, you can do word clouds, and you can count things. But to pull sentiment out, was a person joking? Were they kidding? What's the context? Tough sledding. But that's where everyone's focusing a lot of effort. So I try to keep up with that. And you'll hear more about that, I'm sure, in Data640, where you deal with big data. Ensembles. We talked about ensembles briefly, and more are coming. New types of ensembles. That's kind of become one of the in things. If you can merge and boost some of the models you have in some ways, whether it's a random forest, add a boost or bagging or something else, why not? So there are always ways of tweaking models and seeing if you can get something better. So these are a couple things we have talked about. We've mentioned, or I think everybody sort of mentions, I put these two together, analytics in the cloud and mobile analytics. We haven't done mobile analytics in this course because it's not really something readily available too much yet. But I would anticipate that by the time I get to 2 or 3 more cohorts down the road with 640, we're going to have some kind of a version of a mobile SaaS package or some package from somebody that will allow you to take your analytics on the go, so to speak, and do much closer to a real-time kind of aspect. That means you're going to have to package it a little differently. You're probably going to have to, make it easier to use. Now, I've got links to a lot of things here. I'll just click on them briefly, just so they'll open up. Tableau, which all of you have used in Data600, what mobile sales analytics looks like on Salesforce One. Very interesting aspect, very interesting video. I'm not going to play it tonight, but I think you ought to go look at that when you get an opportunity. I've got lots of links in here tonight because these things are riveting to me and very prescient. They're saying, here's what's coming. And if you want to be early adopter, you want to get in early on when these things are hot and you want to learn about them, then you got to keep up with some of the trends. Okay, a big one, real-time data. All the data we've been analyzing has been past data, but not real-time. We had a data set, boom, happened who knows when, and we analyzed it at our leisure, offline. Well, what happens when the data is flying in there real time? Well, these are some very good links. Again, these are webinars that I've attended in the past. Most of them are quite good. I like TDWI. This one talks about real-time data via analytics, accelerating business to leverage customer relations. Again, remember, you can go watch these webinars for free. Get yourself a TDWI account for free, Data Warehouse Institute. Whenever you see this lady mentioned, Fern Halper, pay attention. She really has her act together and does a great job on these webinars. Very, very smart lady. So that's that one. Here's another one, free analytics from TDWI. So these two are TDWI. The Internet of Things, if you're still wondering what that's all about, well, it's coming. And again, we're going to put hundreds of billions of sensors into everything. And what are the sensors going to do? Collect data, relay data, send data. What are we going to do with that data? So by 2020, 50 to 100 billion things will be connected to the Internet. We've been connecting people to the Internet. Now we're going to connect things to the Internet. And these smart objects will be using connectivity devices linking and exchange messages with arrays of dedicated servers generating 35 zettabytes of data per year. Now, what are you going to do with that data? Well, hopefully you're going to act on it when the time is right. You're going to act on it. Giving you a couple of examples: preventive maintenance. If there are sensors in devices, especially expensive equipment, and those sensors are sending information, and that information has been used to build like a neural net in the past. When that information comes in and the neural net says, oh, high probability it's going to break in a couple of weeks, fix it. And I've already, I think, given you one good example where prediction is doing that for oil field maintenance. The rise of the sensor-based smart city. IBM's kind of the leader on this, but others are doing it too. Used to have a great demo that no longer exists by IBM, and it was Reno, Nevada, and it had sensors everywhere that they had put into things. And not just sensors, but smart programs behind the sensors. So again, when certain things were happening, the predictive analytics kicked in and said, oh, this is going to cause a water problem in hotel, blah, 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 because the sensor is saying that something's backed up or plugged up or clogged up or something. So this one happens to be Rio, and if you want to read about it, they're becoming one of the smartest cities because they're putting all these sensors in and using them to, again, predict things. So they're very interesting. Embedding intelligence and actions in results. I mean, that's kind of the next step. And once we have all this real-time data, we have to then put actions, actionable intelligence or actionable results into what we find. Procter & Gamble, again, I like Procter & Gamble. I follow them closely. For a company that you think of as making soap and stuff, they really are very, very proactive. So aggressive data systems, but they have smart building system that uses predictive analytics to detect building performance abnormalities before they occur. Here's the key. See, most of us grew up in a mantra of, if it ain't broke, don't fix it. Now the mantra needs to change. It needs to become, fix it before it breaks. Fix it before it breaks. So they've got this IntelliCommand smart building management platform. So they're getting energy savings, improved reliability, because if something's about to break, you run in there and you fix it before it breaks. Just one example. Here's another one. This one deals with the supply chain. Again, predicting where there's going to be breakages or slowdowns or disruptions in the supply chain. And I've used some of that in the MBA program. Okay, so real-time analytics, big deal. What does it mean? Well, you know, if you think about it, we all think, oh, well, that means data right now. Okay? Well, I like this definition, again, from TDWI, because it says, you know, there's really a spectrum of real-time analytics. It's a broad concept. There's the right time, you know, that's real-time analytics, delivering data reports at the right time, whatever that is. True real-time, milliseconds or nanoseconds, near real-time, minutes, several minutes, high performance, sometimes close to real-time, on-demand, you could call that real-time, automation, so we have real-time results. And so, again, it would depend on what you're dealing with, right? If it's a surgical operation, you may need to make the decision instantly. If it's something like stock purchase, yeah, nanoseconds might matter. Other things, it might be a day, an hour, a week, a month. So I like this chart. I just thought I'd throw it in because, again, real-time analytics, not necessarily a binary thing. It can be a spectrum. Data types, I like this chart too. Data types handled in real time today. Okay. So what do we handle in real time today? Here they are. A lot of these things. Okay. Application logs. Why? Well, oftentimes you got to stop the bad guys from disrupting the service, denial of service, whatever, right away. So you got to really get on that. Event data, semi-structured data, hierarchical and raw data. Data types to be handled in real time 3 years from now. Social media data. Wow. And of course, this is from 2014, so we're really talking about 2 years. Web logs and click streams, unstructured data. Events, semi-structured, structured, and hierarchical. So these are right now, or were when the survey was done. These are going to be in 1 to 3 years. And these rarely are handled in real time. Okay, rarely. Scientific data. I mean, if you're downloading data from Pluto and you want to look at over, or something from the CERN Large Hadron Collider, and you want to see if you've detected a new particle, you probably don't do that in real time. Raw data, unstructured, spatial, and machine data. So interesting perspective, I think, again, from the TDWI folks, which I find very helpful, again, in putting things into context. Because you can't just rush out there and say, we want everything instantly. Okay, some more things that are changing. Now, some of you have already hit on this, which is, I think, one of the most fascinating things going. It's called deep learning. I mentioned it before. If you haven't had a chance to go out and get the Google Photos app, free, Android or iPhone, unbelievable, because that is Google applying their deep learning for image recognition and putting it out there as an app, so you can upload all of your photos for free to the Google servers, unlimited storage. But more interestingly is once they're uploaded, and I've got several thousand photos up there, you can search on a word like mermaid or cat or cakes or kids or people, and it will pull them all up. And it does it, of course, not by looking at any captions, but by understanding or simulating understanding recognition of what's in the image. And it's all based on the Google deep learning approach. Very interesting. I'll say a little bit more about that in a minute. Where you want to start on this, of course, is to go look at this deep learning lecture. It's an introduction. Let me stop it here. If it's an introduction from January of this year, it's probably the best place to start if you're interested in deep learning. Fascinating. And then machine learning, the state of machine learning. This is also deep learning, state of deep learning in 2014. Now I'm going to say a little bit about what SAS is doing with deep learning in just a minute, but this is pretty interesting stuff here. The state of deep learning in 2014. So these are both good presentations that I've watched. So this I'll say a little bit more about in just a minute. In-memory analytics. Again, one of the best videos I've seen. A little bit lengthy, about 30 minutes long, but basically talking about, and this is a SAS guy, okay, Deepak Ramanathan. This is talking about in-memory analytics. And basically, as you probably can figure out, that means being able to work on all of your data at once. Now, we've worked on some very, very small data sets compared to what we're talking about here. Even some of you who said, well, I had 40-some thousand cases, or I had 400,000 cases, trivial compared to this. If you watch this presentation, you will see it talking about looking at 1 billion variables, not just cases, but 1 billion variables. A data set with 1 billion variables, can you imagine? And what they did for this bank was reduce the time it took to, I believe it's risk analysis, segmenting things, from 18 hours to 12 minutes, because they were able to package it all in memory at once. Now, you do that by parceling it out. SAS has a great way of doing that, which I'll talk about briefly in a minute. Big data goes without saying. Don't need to say much about that. It's big, it's out there, but it's certainly a trend. Cognitive computing. The cognitive computing stuff is really interesting to me because we're talking about making computers that appear to be smart. Again, it's part of this whole mantra of once you have the information, turning it into a decision, acting on it without human intervention. It's also part of the Siri, Cortana, those kind of things, where the agents are able to, it's agent-based learning. So it's very fascinating, okay? Now, what I liked about this particular chart was it gave you a couple of scenarios. So you might want to look at this. What's going on the whole time? And comparing and contrasting, which I thought was great. So there's several links here. This one, of course, the imminent future of predictive modeling. It seems to tie right exactly into what we're talking about. And it's from, if you haven't yet signed up to get your free subscription of Predictive Analytics Times, it's a great online newspaper, I guess you could call it. And they publish several articles each month, well, periodically. I'm not sure it's monthly, but it seems to come out sometimes every 2 weeks. Sometimes you go a month without one. But you can see very interesting articles here while I'm here. The key to modeling success, the variable selection process. We've talked about variable selection, how important that is. Again, most of the data sets we use were small enough where you could literally include all of the variables and probably be okay. But in the real world, where you have hundreds of thousands, or as we saw, billions of variables, that's not possible. You really need to have some ways of paring that down for most of us, unless you have access to unlimited processing power. So you can get an awful lot of stuff here, but this article was really good. Predictive modeling tools, inevitable change, free data science focus on applications and insights. Isn't that nice? It's what we've been preaching here, that the heavy lifting of doing the burdensome computations is gone. So data scientists have to be able to understand the models, build multiple models, compare multiple models, step back and say, now what have I done? What comes out of this that's of any use to anybody in terms of a business case? Am I improving on what they're doing now without this model? If so, how much? Was it worth the cost? Is it worth the effort? Am I going to be able to implement this neural network easily? Can I explain this to the boss? And so forth. So, this is really a great resource that I would recommend for you. The rise of automated analytics. Now, this one is going to hit home because the product that I'm going to show you briefly and encourage you to go look at in detail from SAS that was announced in July, last month, a few days ago, is unbelievable. Well, it looks like you won't be able to get this unless you're a Wall Street subscriber, but I've got a copy somewhere if you really need that. Sorry. Usually I have access to these articles, but they don't last forever. Sometimes they're temporal links and they go away. Deloitte University is also, Deloitte University Press. It's not a real university. It's also very big on all of this as are the other major consulting firms, Accenture, McKinsey, etc. I follow all of them. But, you know, we're talking about putting some artificial intelligence into the predictive model. Now, why do that? Well, because, again, you can automate a lot of the predictive modeling. Think about all the models that we could build in SAS Enterprise Miner. What if you had a rule-based system, which is an artificial intelligence system, said, if this, then hit this button. If this button and this button, then be sure to set this linkage to Bernoulli or whatever. We had some of that right in the help screens. There was some guidance there that if you're doing this, that. Anytime you see if, then, you should think artificial intelligence, especially rule-based systems, because that's what they are. They're if-then statements. They're linked so that they can trigger more than one statement to happen, and they're not always simple. But that's really one of the key things. And in fact, if some of you who had Data610 know that that's exactly what some of the big ML stuff did, was build some rule-based systems of different kinds. So cognitive computing is big. Okay, big data. You know, as you know, I'm a sucker for charts. This one, I wish I had a more current version. You can see it's July 2013. Well, it's kind of neat, isn't it? Let me blow it up a little bit. You can see, you know, every minute of the day, 1.8 million likes on Facebook, 72 hours of video uploaded to YouTube, 2 million searches. This is every minute of every day. Every minute, 72 hours of video uploaded. 14 new songs added to Spotify, 70 new domains registered, 15,000 tracks downloaded, 347 new blog posts, etc., etc., etc. I think it's a neat chart. If anyone finds a July or any 2013, 14 or 15 update for this, please send it to me, because I love this chart. When we talk big data, it's easy to say, oh yeah, big data, big data, big data. It's a lot of data, zettabytes, petabytes, yottabytes. We really lose the bubble. We don't understand that. But when you see it in this form, it seems to have a little more impact. 278,000 tweets per minute. 104,000 pictures on Snapchat. $83,000 of purchases on Amazon. Every minute. 11,000 LinkedIn searches. Every minute of every day. 24/7. Pretty neat. Think about that. So when we talk big data, we're talking big data, a lot of data. And again, that's 2 years ago. God knows what this thing is now. Okay, now let's talk about deep learning. I hope some of you, if you've been watching the discussions, I've posted some of the links that are my favorites to deep learning. I've got some more in here tonight. But this is just amazing to me, okay? Since we've been through the neural networks portion of the course, you have enough of a grasp of what's going on with neural networks to sort of figure this out, although not completely, or I haven't figured it out completely. But if you watch the SAS deep learning networks demo, it's probably the best way to learn it. But what deep networks are, the concept's been around for a while, but now we're starting to see some real results, such as the Google Photos. That's the best result, I think. What deep learning networks are multi-layer neural networks. You say, oh, what's the big deal? Well, what the big deal is they seem to be able to do this and recognize video and pictures and other things that were heretofore impossible. Now, as you know, a neural network takes a lot of inputs and then squishes them down into a middle layer or a hidden layer, right? Well, with a deep learning network, what ends up in the hidden layer become the inputs for the next hidden layer. So you train it one layer at a time, and each layer has fewer and fewer nodes. And you can see we eventually get down here where we have to choose between, like, well, when you finally get over here, a cat and a dog. Now, as silly as it sounds, what this is a giant feature extractor, okay? Extracting the key features, but getting down to a small number. Google, for example, fed its deep neural network, which, remember, you have to train a neural network on past data, 2 million pictures of cats. And they got to where they announced, I was probably 6-8 months ago, they said, guess what? Our neural network, our deep learning neural network can now differentiate between cats and dogs. In other words, it's almost never going to make a mistake of thinking a cat picture is a dog picture and vice versa. And the world went, ho hum, big deal. I can tell cat when I see it myself. Well, yeah, but when you take that same technology and now apply it to images of other types, hence 2-3 months later, here comes Google Photos and other applications. It's really impressive, trust me. So these are multiple layer neural networks. They go from edges to textures to parts of objects to whole objects. Now, the concept to me is still not as clear as I'd like it to be. I've watched the videos many times. I'm starting to catch on. I see sort of how it works. It's almost magic, which I thought neural networks were when I first learned them. So I'm going to work on this much more. We probably won't ever get to do much of this in 640 course, but it's fascinating to keep an eye on. So we have nonlinear functions that are combined to form a complex nonlinear function, which can map things such as raw pixel values to image categories. I have to read the slide as well as you, right? So we keep reducing the features. We have fewer and fewer neurons in each hidden layer until we get down to where we have a result that comes from, amazingly goes from, in the case of the SAS demo, it's a 784 pixel thing, ends up basically paring that down to just a couple of pixels, and you can tell what it is. So, computationally intensive. Because these multi-layer neural networks have to train one layer at a time, everyone keeps warning me every time I watch any of the videos that they are computationally intensive. Well, if something's computationally intensive in this day and age where we have almost unlimited computational power available, it must really be computationally intensive. Okay? They keep warning you. Some early success stories, and again, you can get this from this article if you have access. I'm a member of the ACM, so. Identifying German traffic signs, 99.4% accurate. Identifying images, 15.8. 30% improvement in speech recognition, identifying molecules. And this was a couple of years ago. Okay, this, you can go see this article in the New York Times. You should be able to still access that, I think. And get a lot more background on deep learning. Yes. Growing speed and actual deep learning. And again, it's a strange concept. This guy, Jeffrey Hinton, that I've followed for a long time, because he went from being called kind of a kook to being called now brilliant. Okay? He came up with this concept some time ago, but long before we had the processing power and software and everything to do anything about it, other than his software. There were Hinton models, he called them, many years ago. Okay? The best way to do this is go watch these demos. Okay? Demos/webinars. They are fascinating, riveting, but they will really get you going on this. How it works. Oh, I'm sorry. That's different. Okay, so deep learning. I'll scroll ahead real quick to SAS specific deep learning. This is one of the best places to start because this is a short 15-minute demo, which is very good. Anyway, okay, get back to deep learning. I'll come back to that when we get to the SAS stuff. Watson Analytics. I mentioned this also last week because I wanted you to know that it was one of your options. And again, you really need to go watch it to see what's going on. Again, this ties into what we call automated analytics, in that Watson says, stand back, I'm going to do just about everything for you. I'll figure out from your data set some key questions you should be asking about it, which could be the questions you actually want to do for your analytics, problem. It may very well be one of the key questions that comes out of the Watson first step is, in fact, the question you were thinking of doing. You know, we talked about framing in Data610 and how important it is and how hard it is to get it exactly right. Well, Watson says, you know, based on your data, here are some things you could ask about that. Here are some things you could predict from that. Really fascinating. Then it says, okay, let me build you the model. Now, it really focuses on decision trees. It doesn't really build a lot of other kinds of models. So it focuses on that. And then it, of course, gauges the accuracy, and then it comes back and says, want me to turn that into a dashboard. So it's pretty neat and catching on. As I mentioned last week, it is not the embodiment of Watson, the big brain that won the, all the contests going on, including Jeopardy. But it's called Watson Analytics, and the hope is they're going to marry the Watson brain engine to that. But I thought it was a little false advertising to call it Watson Analytics when it really doesn't have the Watson engine behind it yet. Still, these are the kind of things, if I were going to be a data scientist or planning a career, I'd want to keep an eye on automated analytics. I want to say, you know, how far does it go before it impinges on what you, the data scientist, can do? Or will there always be a good spot? I think there'll always be a good spot for the data scientist who understands the models, who can explain the models, who can apply and assess the models and certainly apply them to a business problem, you know, do the storytelling, etc. Now, those are softer skills to a degree, but I think they're going to go part and parcel with being a data scientist because, the computational effort is going to become less and less and less. And things like Watson Analytics and about to be announced here in a few slides, Factory Miner from SAS, are going to just make this amazing. It is amazing. So watch these videos. They're all quite good. And you can get a free Watson Analytics account, by the way. I mean, again, has anyone out there done that that's here tonight? I know some of you were considering doing Watson. If again, you need your IBM account, which is free. You need Watson. And of course, you have a limited amount of access, but that's okay. For anything we're doing, it's plenty. And I've used it. And we had a couple of students last semester take a shot at comparing Watson Analytics with SAS Enterprise Miner. You know, we'll put a problem in and so forth and compare what they do, how they do it, the result, how understandable, how accurate, etc. So that's one of your options, remember. Okay, before we talk about the SAS specific things they're doing, I'm not here as a SAS representative, but I did want to give them a little mention because we used their product this semester. I wanted to give you another perspective. This is from the top business intelligence predictions for 2015, okay? And this is by a company called Panorama. I'm not familiar with them, but I thought, let's look at what they say. Visual BI redefined. Well, we all know visual is important. Democratization of insights. In other words, sharing more, collaborating more. Cloud gets traction. Real time, mobile, agility, big data servers, BI collaboration, automated predictive analysis. There it shows up again, the Internet of Things. And I thought this was a pretty good list until I found the TDWI list, which I think is a little bit better. Similar, but a little bit better. And again, this is right from a recent download, 2015. So you can go download your own copy of this. These are perspectives that apply quite nicely to what we've covered in this course and what you're going to continue to learn in the MSDA program. Ease of use. Ease of use. Analytics in the past required command line code. Today, vendors, and I bolded this, the interface is easy to use and visualization is easier to construct. Well, you've seen both. You saw this with Tableau. You've seen the interface is easier to use with Enterprise Miner. If we had tried to learn SAS-based code, it would have gone much more, we would have had to go much more slowly. We would have been lucky to get anywhere close to being able to build the multiple kinds of models, interpret them, run excursions that we did. Okay, so the vendors are moving towards the visual interface, the drag and drop, something easier to use. There'll always be a place for some people to write code, but I think it's going to be diminished in terms of the things like the SAS code. are, certainly. Maybe that'll continue. Democratization and consumerization, big words of analytics. Okay. Broad range of non-IT users from executive level to front personnel to do more on their own with data access. Again, I think you can see that there could be, certainly in 610, something like prediction or big ML, end users could do a lot of their own analytics. SaaS Enterprise Miner certainly would take a little more training, but you still could master a relative level of that. And I think you're going to see when you see Factory Miner, you could even do more. So, that's what business analysts using more advanced techniques. That would include things like ensembles, more complexity, more multiple models. So these are trends that, again, just came out not too long ago. That's why I had to revise all my slides recently from TDWI, a well-respected outfit. Newer kinds of analytics. What do I mean by newer kinds of analytics? Well, again, I bolded some key words. Text analytics, social media analytics, clickstream analytics, Internet of Things analytics. So I've already covered those, but they agree this is a hot trend. Operationalizing analytics, one of the other trends and mantras that I've preached for several semesters now is you got to turn your results into something operational to make a difference. It's fun to build the models, but if you can't turn the models into something operational and make an impact on the business, what did you do? You had a lot of fun, you screwed around, you hit some buttons, and you got a model. But the business wants to say, what can we do differently? Who do we mail to? Probably the best example, if you want to go back, anybody needs the link, I'll post it. But if you recall, back in Data610, those of you that had Data610 from me, and uploaded these many semesters ago, there was one example from a company called 11 Ants, where they took and built a churn model. Well, we've built churn models, so we know how to build churn models. I think it was a regression model or something. They built the churn model. Then they took the churn model, and here comes a new list of potential of current customers, and you'd like to do what? Well, you'd like to say, okay, since I now have a model that can predict churn, let me apply to my current customer base and try to figure out who among them are likely to churn and take some action. Right? That's the whole purpose of building the model. To build the model was built on past data, but you want to use it, you want to score current data, and that's what scored means. So they scored all of their current customers, and they each get a number between 0 and 1 likelihood of churning. Okay. Then what? Well, then they went, in that little video, it's about 20 minutes long, then they went and said, okay, what if we offer each of these characters a $50 coupon if they'll re-up for another year or something like that? This is close. Well, I can't send it to everybody. If I send it to everybody, I'll go broke. So where do I send it to? People who have a 0.8 or higher, people who have a 0.7 or higher likelihood of churning, a 0.6 or higher, 0.5 or higher. Oh, where do I send it? Good question, isn't it? You see, I've got to translate my neat model, which gives everybody a number, a likelihood of churning, probably a logistic regression probability of churning. I've got to translate that into something actionable. So what they do in this little video is they go through and say, what if we gave it to the top 10%, top 20%? Let's see what our profits should be. Here's the value of keeping a customer who might have churned. Here's the cost of sending a coupon to someone who wouldn't have churned, and so forth. It's a very interesting little study. But I've always thought it was one of the neatest videos because it took it the next step. And I've got to do more of that in all of our courses. We've got to be able to show more ways of operationalizing, because that's what you're going to do in your practicum. Yeah, you're going to build some models, but you're going to have to do something with them in your practice. Okay. Continuing with the model, big data. Well, we don't even say about much big data, but it says, we're going to have to develop new techniques for data analysis. That's part and parcel of why that in-memory analytics is going to be so important. It may be part and parcel why we want to get mobile analytics. We want to get analytics in the cloud because big data forces you to do things differently. New development methods, interesting, isn't it? Analytics demands a different methodology from what has been used for traditional IT projects. Couldn't agree more. Greater business IT collaboration, faster, more iterative development cycles. What else? Open source. Now, of course, We have not been using an open source product here. SAS Enterprise Miner is not open source. It's free for our use, but it's not open source. But in our program, you notice we do teach R language, and we're going to probably beef up our teaching of R language. And same thing with Python. You got to learn some of these open source languages. You may end up with a company that can't afford any of the SAS products or other products and needs the power of R and or Python, two very, very powerful open source programming languages. And so open source is important because it fosters innovation, as it says here, and it does. The cloud. Why are people moving to the cloud? Because of the cost of infrastructure. Why in the world would you want to buy your own servers or your own software if you can run everything on the cloud? You know, you need maintenance, you need personnel, you need hardware. We've been running on the cloud, so we know how that works. When the cloud is available, it's great. When the cloud is backed up or not available, or there's too many people trying to use the SAS product, it's a little bit annoying. What else? Mobile, of course, goes without saying. Executives on the go. Now, the best example of mobile analytics by far is UPS. Again, at the Predictive Analytics World Conference, the UPS presentation was riveting because they go hog wild into analytics to try to save. If they can save 1 minute per truck per day, it's like several $1 million a year in terms of bottom line. Storytelling. How about that? Storytelling made it into the top trend, 11 trends. It was 11, but it made it. You must be able to tell a story about the technologies. And again, we have focused on that. You must be able to do more than just crunch the numbers. You have to go in and explain what you did in English and make it sense, frame the problem, sell the answer, tell what you did, and use storyboards or whatever you got to do. Good graphics. So I thought that was good. Again, they also talked about, or Fern Halper did, my friend, well, I don't know her, but I think she's a good gal, talked about some drivers, decision-making, understanding customers, and improving business most important drivers for progress. New revenue, certainly a driver. All companies want to make more money. And driving real-time actions. Analytics is useful only when acted upon. Much of the market is not yet mature enough to implement real-time actions or take actions in real-time events. So we're going to get there. Some more survey key results. Next generation platforms mean pushing past reports and dashboards to predictive analytics. Yay! Technologies such as this, and this, poised to double. This was January 1st presentation by Fern Halper, or survey rather. More than half of respondents cite skills as a top challenge, followed by understanding the technology. That's what we focused on in this course, I hope. Company using analytics for decision making, 6% more profitable, and then use cases. Boo, boo, boo. Well, as we know, their use cases are everywhere, so we don't have to worry about that. Next generation challenges, skilled personnel, understanding technology, not enough budget, boom, 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 boom. Popular current and future technologies, predictive analytics for structured and unstructured. Now remember, if you go back to that chart that I showed you about the second or third slide with all the bubbles on it, there was one at the top called prescriptive analytics. Predictive analytics, of course, gives you, here's what's likely to happen. Prescriptive analytics suggests or automates action to produce an optimal result. So this is the big step from going from predicting to implementing and using things like rules and automated systems to guide this. And of course, text analytics. Those are popular and current and future technologies. Finally, what kinds of analytics do you use in your organization today? Again, this was January of this year, a few months ago. And where will you be 3 years from now? So this gives you a good feel on what's growing, okay? What's growing. And you can see there's several things here. For example, predictive analytics, about a third, a little more than a third using it today. Plan to use it within 3 years, it's going to double. Okay, and then for folks with no plans, they're going to get left behind, in my opinion. Risk analysis, web log, fraud, look at them all. Prescriptive analytics, that's going to go from 23% to about 64% in 3 years. Remember, we're 6 months into this. Who uses it? Well, business analysts are the big users. Data scientists are the big users. But look, the business users are catching up to other people. Executives are even starting to use it. Okay. Now let's talk, in the last few minutes, I want to talk a little bit about what is SaaS doing. Because if I'm going to continue to use their product, I'd like to be comfortable in knowing that they're on top of these trends. I'd like to feel a good, warm, fuzzy feeling that says, oh yeah, the SaaS people are still working this hard, the same trends that I've talked about here briefly tonight. And it turns out they are. First of all, as I said, this deep learning demo is quite impressive. 784 pixels to describe a number, and they show how you can squeeze that down quite nicely. It's a very interesting demo by a very smart guy. I didn't say I understood everything he did. He keeps saying, look for my part 2, and I haven't found it yet. But this is really impressive. And again, I got a couple slides from his presentation. Rapid predictive modeling. I didn't mention this earlier in the course, but I will now. There is another SaaS product called RPM. I saw it when I was at the SaaS class, which was a year ago, when I went to their free for professors program for a week. They showed us right at the end of that week, RPM. RPM automates Enterprise Miner even more. So you have what? Fewer options, more things decided for you, more things created for you automatically. Again, you can go watch this in action. So it's called Rapid Predictive Modeling. It says, you know, maybe we know more than you do, or maybe you're not very experienced, don't understand all the various buttons and options we have. Let me build the models for you. And it's called RPM, Rapid Predictive Modeling. It's using Enterprise Miner in the background. So it may look very similar, and what's going on is once you tell it, yeah, I have to build a neural network model, it says, okay, get out of the way. Boom, 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 and it uses Enterprise Miner, but it does all the settings for you. Now, does it know enough to test every appropriate setting for every appropriate kind of problem? No. But it does know quite a bit. And I think the enterprise models that are created, you can go in and modify them. So this is a quick jump start. This will create a bunch of models for you right away. Go watch these videos and look at the communities thing. You'll be impressed. We don't have access. Going back to the deep learning, this is what's in the video that if you go watch the SAS one, you're trying to use something called a denoising autoencoder to go from 784 neurons down to about 3. And then you train all of them together. It's really interesting. That's all I can say. It's pretty fascinating. You'll learn quite a bit because the guy around it does a decent job of explaining a pretty complex topic. RPM, those were, again, Rapid Predictive Miner. Customized task that runs pre-built SaaS enterprise models. So if you have a customer acquisition, if you have a churn, if you have an ROI, if you have an upsell, a cross-sell, retention, and others, these are already built. It says these are the most common things that happen. We've already built some really good models, some champion models that you should use with settings. It's available as a task for SaaS Enterprise Guide. It's an add-in, they say, from Microsoft Office. It requires Enterprise Miner 6.2 or higher. So it's been around a while because we're now into 14.1. Enables business users without prior statistical knowledge to build predictive models quickly and effectively. There's also a danger to that, isn't there? Because it comes back to the storytelling. Yeah, you can hit a button and have a model. Are you going to be able to articulate that effectively to the bosses? You can't just run in there and say, this thing built a neural network model. I have no idea what that is, but it looks really good. Let's do it. You're not going to get very far. At least my experience has been you don't get very far. Produces results with simple and easy to understand charts, which is good to support better decision making. So it's certainly worth a look. And some organizations may find it rather effective, but I still think you need somebody to sort of poncho that. What does it do? It enables you to choose between basic, intermediate, or advanced pre-built models. So you do have some choices. Handles outliers, missing values, rare target events, skewed data, variable selection, and model selection. Wow. See, if we had this, the course would only be a week long, wouldn't it? Produces reports that are easy to understand, lift charts, key variables and terms, enables analytic experts to further customize. So they could build something like this, the business analyst or the end user, and hand it over to you, the data scientist. So you could say, I got to tweak this a little. Enables registration of the models and the metadata in order to automate the execution of score code and ease the model's deployment. Wow, pretty neat stuff. Now, SAS also has something called high performance analytics. This is where it basically takes a large data set and parcels it out to multiple processors. And they all work on little pieces of it and then pull it back together. Now, think how complicated that is, because you can't parcel it out and have everybody doing something totally different, never pull that thing back together and make any sense out of it. So it has to be very clever in the way in which it sends the information out to the various processors and is able to pull those back. And where is it useful? Well, it's useful for when we talk about Teradata data files. Teradata data files are huge. SAS does have a relationship with the Teradata people, an alliance, if you will, that lets SAS users upload very large data sets into Teradata data sets. I would like to do more with this, quite honestly. I was very surprised to find out this semester that apparently our HPA node does work. So, maybe we can do that. But of course, we're still probably restricted to only one processor at the SAS servers. I mean, you have to have the high performance nodes are less capable in terms of options than the regular nodes. They have fewer options. But for large data sets, they can parcel it out to multiple processors and then still pull it all back together. It's really impressive. And then the final thing, just announced this July. SAS Factory Miner. Now, when I first saw this about 3 weeks ago, I thought, oh my goodness, this is Rapid Predictive Miner on steroids. What, if you go look at this demo, which is relatively short, I think it's only just a few minutes long, and I don't think, if I play it now, I don't think the volume would come through, but if you go look at it, it's slick. But I'll explain a little bit of it while it's playing. I don't know if you're going to be able to hear the volume, because it could be my headset, not yours, not going through my speaker. Anybody hear that? No? Probably not. Probably can't hear that. But let me tell you what it does. I'm just going to let it run for a second, but get over here a little bit further. It produces segments of your data, and then it goes through. So it segmented the large data set, and the segments were from different states, clearly. Then it went through and tried a whole bunch of models, compared them all, and said this is the champion model for each segment. And then it goes and builds the accuracy charts and everything. So it's really, so you can see some of them, the random forest was the best, some of the neural nets. There's some here where regression was the best. Here's one where decision tree was the best. The one thing I do walk away with immediately is what we've been saying throughout this course, that no single technique is always the most accurate. It's true. Because here they had several segments where various different kinds of models came up as being the best model. Random forest, neural nets. I'm sure there's a regression or two winning somewhere down in this pile. So again, I would say go look at this short little demo. This is a new product. I've already sent a message to SAS, haven't heard back yet, saying would we have the ability to use this in class, perhaps next semester, at least for a demo. I haven't heard back. So I'm not sure they've made a decision about whether this will be available for any academic use. But let me tell you, it's pretty impressive. Now, you can also, I've got a couple more slides. Here are the features, okay? Customizable templates. So the templates are in there, but you can go in and tweak them. Self-service machine learning techniques, regression, logistic, decision trees, random forest, blah, 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 blah. And then it picks out, it builds all these models for every piece of your data. And then it picks the champion model for a variety of interactive assessment techniques. So you can say, I want to assess them on average squared error, or I want to assess them on ROC curve, or I want to assess them on confusion matrix. Model exception identification. You can fine tune the models. You can retrain the models. You can scale the models. Flexible deployment. It says it's an add-on to SAS Enterprise Miner. Okay, so I'd love to add that on. It just came out. Watch the demo. I know I've been saying that on every chart, but watch this demo for sure. Here's another chart, again, showing some of the various things. You can see generate the champion models for every segment in your data. Okay, it's going to generate and give you all kinds of stats and numbers and pictures. Very impressive. Okay. All right, last slide. As always, the hour's about up. What's left for you to do? Well, your final assignment, of course. And as always, if you have insights you'd like to contribute, feel free to do so. You're encouraged to do so. Questions, ideas, links. And some of you have done a real good job in finding things this week on either deep learning or other things. If you find more things on Factory Miner, Rapid Predictive Miner, any of these other interesting things, feel free to post them there, because I like to aggregate those things and make them available all semester to semester. And of course, I learn from those things. I go and watch as many of them as I can and try to absorb what's next, what's coming, because whatever we're doing this semester will likely change as some of these other newer approaches, newer tools come along. Nonetheless, the base and foundation you've established by hopefully understanding what's going on in the techniques we've covered should serve you well going forward. I think it's going to be quite a fun time in the world of analytics to watch all this stuff unfold, and of course, hopefully a very good career move on your part to get into this field while it's so hot. Okay, with that, I will stop and say, as always, if there are questions right now people wish to ask, feel free. Or, as always, during the week, remember the deadline for all assignments is the Sunday, August 9th, midnight, Eastern time. With that, I'll say bye. Okay. Well, thank you. That's great. Okay, well, be sure to go watch. If you're only going to watch one, I would watch Factory Miner, and then the other one I was going to, if I had to watch one other one, I would watch something on deep learning. Those two are just fascinating to me. Okay, I'm going to go ahead and stop the sharing, as always, first step, so I don't screw this up. And then I will stop the recording.